And these are the solutions to Unit Test 2, and specifically questions numbers 1 through 9. Very little in the way of problems collectively, did very well as a group, about 200 students who seemed pretty good with rational expressions and factoring now, both looking pretty good. Um, Number one here, 5 minus x over x squared minus 25. The x squared minus 25 obviously factors difference of two squares into an x plus 5 and x minus 5. And then swapped around a minus sign, x minus 5 and 5 minus x are signed opposites. So they cancel, but not one for one. They cancel one for minus 1. And so from there, we get a final answer on question number 1 of negative 1 over x plus 5, or variants of that. Of course, you could distribute the negative sign through the bottom, so you could have had 1 over negative x minus 5. And there's some other variations that might have been there, but for the most part, that's what we saw about 90% of the time. Number two, this is just a rational expression, factor the numerator, x minus 6, x plus 1, factor the denominator, difference of two squares, x plus 6, x minus 1, the x minus 6's cancel. You're left with a final answer of x plus 1 over x plus 6. And little to no problem there. I think everybody had that question right. Number three is simply factor completely. If you made this first step and stopped, then you wouldn't get full credit for that, because the 16 minus x squared factors further. Again, that first step in factoring, look for a common number and or letter, look for a common uh, greatest common factor. In this case, that would have been a 3. And then the 16 minus x squared factors easily into a 4 minus x times a 4 plus x. So that's done. Number 4, rational expression. Factor the numerator. Greatest common factor is 3x. You divide out of 3x from each of those, and you're going to be left with an x minus 1. Again, factoring is dividing. So 3x squared divided by 3x leaves you with an x, and minus 3x divided by 3x leaves you with a minus 1. The bottom, difference of two squares, factors easily, and you got a cancellation, multiplication, division, inverse operations. Final answer on number 4 be 3x over x plus 1. Right? Should have been your final answer there. Number 5, adding rational expressions. Okay, adding two fractions. So you want to compare the denominators. Um, and in taking this second fraction, factor out the 2, and you look at the denominator there. Now it's 2 times the quantity x plus 3. Compare it to the first term's denominator, which is merely an x plus 3. And the easiest way to handle this then would be multiply the numerator and denominator of that first fraction by 2. Remember, whatever you do to uh, denominator, you have to do the same thing to the numerator. 2 times 1 is a 2, and of course plus the x, and you were finished there. There was no canceling. If you wanted to, I think you could have distributed the 2x plus 6, get the 2 times the x, the 2 times the 3 in the bottom. I believe it would have still counted that as correct. All right. Number 6, factoring exercise. And first thing we notice is that they're all multiples of 2. So we divide out that 2. That leaves us with an x squared, a minus 2x, and a minus 30. And then the x squared minus 2x minus 15 factors easily into an x minus 5 and an x plus 3 in some order. And so there's your solution for number 6. Okay. Number 7, maybe an easy way, a difficult way to do this, depending on how you saw it. You had u plus 1 plus u over u plus 1. Well, simplest way to think of this is think of that u plus 1 quantity, think of that as all being over 1. And then, as we did in number 5, see it as two rational expressions that you're adding. Of course, the one on the right has a denominator of u plus 1. The one on the left has a denominator of 1. In order to match them up, we would multiply by u plus 1 on the left. And so we consequently have to do the same thing to the numerator there. So we multiply by u plus 1 over u plus 1, multiplying by 1, and that will give us that common denominator of u plus 1 that you see right here. Now, additionally, that numerator on the left, this should actually be a u instead of an x. There we go. So we got u plus 1 times u plus 1. That's going to give us u squared plus 2u plus 1. This pair right here multiplied together, right? U squared plus u plus u plus 1. And collect the two u's right there. And then finally, in the numerator, the 2u plus the u from the right-hand fraction gives us a 3u. Then algebraically prime, the u squared plus 3u plus 1 cannot be factored, and so that would be your final answer. Number 8, multiply a pair of rational expressions. Note the difference between adding rational expressions in 5 and 7 and multiplying rational expressions in number 8. Multiplying, you do not need a common denominator. You merely multiply numerators, multiply denominators, but first it's advisable in the algebra world, certainly, arithmetic as well, of course, to factor. And so x squared minus x minus 6 factors to x minus 3x plus 2. Make sure you're getting that factorization. X squared plus 2x factors to x times the quantity x plus 2. The numerator on the right, factor out the greatest common factor x squared, dividing out the x squared, we get x plus 1. And finally, an x minus 3 and an x plus 1 in the denominator on the right. Finally, as you look around and begin the process of canceling numerator to a denominator, remember, the x plus 2 with the x plus 2, and obviously the x plus 1 with the x plus 1. And finally, since x squared means x times x, we've got a cancellation of x with one of those x's. And so your final answer for question number 9 is just an x, and that x is in the numerator. So no problem there. Finally, last one for this video, number 9, going to go with pairwise factoring. Going to go with factoring by grouping. So look at the first pair. You have 2x cubed minus 3x squared. And the last pair appears at first to have nothing in common. From that first pair, if you factor out x squared, divide out the x squared, you're left with 2x minus 3. Make sure that makes sense to you. Right? And then on the last pair, if I divide out a minus 1, then minus 2x divided by minus 1 is 2x. And plus 3 right here divided by minus 1 is minus 3. So make sure you understand this step of how we factor out a negative 1. And then you notice that both pairs have the 2x minus 3 in common. So we factor out the 2x minus 3 from each one, right? You're just building a factor tree. And so you've got 2x minus 3 times x squared minus 1. X squared minus 1, difference of two squares. That gets factor treed out to x plus 1 times what should be an x minus 1 right there. Let me change that to an x minus 1. And so your final answer on question number 9 should have been x plus 1, x minus 1 times 2x plus 3, of course, except for order. Can be in a different order by commutativity. So that's questions 1 through 9. And again, no problems. Very good job there by people with that. So we'll see you later.